The geomorphic process operated by the river or running water is called as fluvial process. The basic question here is that under which climatic conditions fluvial process operates. The fluvial process of landform development is mostly seen in the humid region, which receives very heavy rainfall. Next question is what type of work the river undertakes in the evolution of various fluvial landforms. The river undertakes number of processes to develop various types of landforms. In this session, we will try to understand what are these processes and how do the river operate these processes. The main objectives of this lesson are to understand the nature of the river flow and the processes undertaken by the river, to understand the concept of base level, to understand the concept of river profiles and profile of equilibrium. River is the naturally flowing water course flowing towards the sea or a lake. Rivers are a part of the hydrological cycle. Water keeps moving in the environment of the earth continuously in the form of hydrological cycle. Surface flow of water is an important component of this cycle. Water flowing on the surface, not following any distinctive channels, is called as overland flow or runoff. Stream flow is because of rainfall, but the rain may fall upon the earth's surface without producing streams immediately. Runoff precedes stream flow. There are two components of river flow. One is overland flow and another is linear flow. Overland flow causes sheet erosion. Generally, water collects in a river from the precipitation or rainfall through surface runoff. On the lower slope, this flow may attain the identity of a stream. The formation of river channels is the result of the erosional capacity of the stream. In areas receiving sufficient rainfall, the surface flow leads to the development of river system or drainage system. A river is a network of connecting channels through which the water falling on the surface is collected. A river system consists of main channel and all tributary channels flowing into it. The total land area drained by the river system, including its tributaries channels, is called as the catchment area. All the rivers have a starting point from where the river begins to flow. At the point of origin of flow of water is called as the source or headwaters. The other end of the river flow is called as the mouth, where the river water empties in an ocean or a sea. River flow is highly complex system influenced by number of variables like discharge, velocity, slope, sediment low and base level. The most important variables in the stream flow are discharge, velocity and gradient. The stream flow is influenced by volume of water or discharge. Discharge is the amount of water flowing into the river during the specific interval of time. It is usually measured in cubic meters per second. Discharge increases downstream as more and more water is added from each tributary. River flowing from high altitude to low altitude under the influence of gravity. Velocity has a direct relationship with slope and gradient. Steeper the gradient, the more rapid is the stream flow. Low gradients produce slow or sluggish flow. The velocity is usually greatest near the center of the river channel and above the deepest part. Volume of water also affects velocity. Greater the volume, faster is the stream flow. The velocity of flowing water in a given channel also depends on volume of water. That is, greater the volume, the faster the flow. Well-defined river channels do not develop in areas of low rainfall. The erosional capacity of the stream depends mainly upon its volume and velocity. The velocity and volume of a stream together constitute the discharge. The river performs three types of work: 1. Erosion, 2. Transportation, and 3. Deposition. Erosion is a dynamic process which involves the removal of the geomaterials. Erosion is the process involved in the wearing away of the land surface. River or the running water is the most important agent of erosion. The sediments carried by the river or the load carried by the river will act as erosive or cutting tools. The erosional work of the river depends on the channel gradient, the volume of water, the sediment load. The sediment load will act as tool of erosion, etc. Erosive capacity of the river becomes maximum when the river is having a steep channel gradient. Optimum amount of load with high velocity. The velocity of water flow depends upon channel gradient and volume of water. The erosional power of the river is proportional to the square of the velocity, which means if the velocity is doubled, the erosional power of the river increases 4 times. The sediment load of the rivers includes rock fragments, gravels, sand, silt, and clay. The erosional work of the river is performed through 1. Mechanical erosion and 2. Chemical erosion. Now, mechanical erosion. Mechanical erosion comprises corrosion or aberration, hydraulic action, and attrition. Chemical erosion involves corrosion or solution. The erosional work is therefore performed mechanically or chemically. Generally, most of the erosional work of the river is performed by mechanical means. The mechanical erosion caused by the sediment load carried by the river is wearing rocks from its bed and its bank. Some of the rocks over which the river flows, like limestone, are dissolved in the water. The process of dissolution is called as chemical erosion. The erosive work undertaken by the river is mostly undertaken by 1. Aberration or corrosion, 2. Attrition, 3. Hydraulic action, and 4. Corrosion. Aberration or corrosion. Aberration is the mechanism of breakdown of the rocks by the erosional tools carried by the river. The nature and the magnitude of aberration depends upon the nature, size, and angularity of the erosional tools like rock boulders, pebbles, etc. Aberration by the rock debris carried by the river greatly aids erosion. Rock fragments moving downstream strikes against the rock along the bed and sides of the river channel, thus aberrating and breaking them. This action is called as aberration or corrosion. Now, attrition as a process of river erosion. The rock fragments being transported by the flowing water also collides with each other and get disintegrated into smaller and smoother particles. The load of the river, such as rock boulders and pebbles, etc., while moving with water, collides against each other and thus fragmented into smaller pieces and finer materials during the transit. The rock fragments transported may thus be converted into fine sand and silt. This process is called as attrition. It is thus seen that attrition is the mechanical wear and tear of the erosional tools themselves. Hydraulic action. Hydraulic action refers to the physical force of the running water. The force of the running water mechanically breaks and moves the rocks in its transit. Hydraulic action is the mechanical loosening and removal of the material of the rocks by the force of water alone. Solution or corrosion. Some of the rocks over which the stream flows are soluble. Solution involves the removal of soluble materials from the parent rock. This process mostly operates in carbonate rocks. Most of the salts are removed from the bedrock, through which the process of carbonation. The water dissolves the rock along their joints and makes cavities through the solution action. Solution is an example of chemical erosion. Now let us talk about the base level. J.W. Powell postulated the concept of base level in 1875. There is a maximum limit up to which the river can undertake vertical erosion or valley deepening, beyond which it cannot undertake downward erosion. The limit of maximum downward erosion by a river is called as base level of erosion or simply as base level. According to him, the sea level is the ultimate or permanent base level, which is termed as grand base level. The grand base level depends upon the position of the sea level. It means that any changes in the sea level in the desert or the arid region, the drainage is called as internal drainage, where the river ultimately ends into a lake. In the region of inland drainage, the base level is the lake. The lake is thus called as local base level. Some rivers do not end up in a sea but end up in a place like lake. Local base level is higher than the sea is known as local base level. The erosional work of the river is undertaken by 1. Vertical erosion, which is called as down cutting or valley deepening. 2. Lateral erosion, which involves the widening of the river valley. 3. Headward erosion, which involves valley lengthening. Vertical erosion. In the initial stage of the valley development, the river cuts mainly downwards. That is, river deepens the valley by vertical erosion undertaken by the process of corrosion, aberration, hydraulic action. Vertical erosion is prominent when the river in the initial stage or the mountain stage. Due to the vertical erosion or down cutting, V-shaped valleys or valleys with steep slopes are formed. Lateral erosion in the mature stage of the river, there is more lateral erosion than the vertical erosion. Valley widening can be accomplished by lateral or side erosion, erosion of the sides of the valley. Lateral erosion by the river is undertaken through hydraulic and corrosive action. Lateral erosion increases the width of the valley. The valley side profile or bank-to-bank profile of the river is called as cross profile of the river. Headward erosion. Valley lengthening takes place due to headward erosion. Headward erosion increases the length of the stream. The river meandering also increases the length of the river. The profile of the river from source to the mouth is called as longitudinal profile of the river. The curve of the long profile of the river is concave in shape. The slope of the river channel is steepest at the head and decreases downward. Rivers are important agents of transportation also. It obtains weathered material of different size and transport them from the upper coast to its lower reaches. The material being transported by the river is called as its load and it may range from large boulders and pebbles to fine sand and silt. The load of the river is the amount of sediments which the river carries with it. Rivers transport their load in different processes by 1. Solution, 2. Suspension, 3. Saltation and 4. Traction. Solution load. The solution load of the river includes materials dissolved in the water. The soluble materials are dissolved in the water and becomes invisible. Such material is transported in solution. Suspension. The fine and medium size materials are suspended in water due to its buoyancy. Such load can be easily carried away by streams for a longer distance. The finer particles of the sand and silt remains suspended in the moving water. They constitute the suspension load of the river. Saltation. Saltation involves the transportation of rock boulders of big size which moves as bed load close to the channel floor by rolling and sliding. The mechanism of saltation involves the transportation of the load with water currents, wherein the coarse load moves downwards, leaping and jumping through the valley floor. The mechanism of transportation of the load is extremely slow. The load is too heavy to remain suspended in the water, but it is light enough to move bouncing and jumping along the bottom of the stream. Then traction. Larger rock fragments move along the bed of the river. The load is called as traction load or the bed load. The traction load more or less touches the bed of the river. The transportation of the bed load by traction, the size of the sediment determines the process which the load of the river is transported. The fine sediments are transported in suspension. In most of the major rivers, the fine particles of silt and clay remain suspended most of the time. Coarse sediments or the load of the river are moved by traction and saltation by rolling and sliding along the stream bed. Dissolved material is carried in solution and is essentially invisible. The river starts depositing its load when the amount of load being carried exceeds the transporting capacity. Reduction in the transportation capacity of the river are due to reduction in the decrease of velocity. The decrease in the stream velocity is due to the decrease in the channel gradient. When a rapidly flowing stream emerges from its source or from the mountain and reaches relatively a flat area, its velocity reduces significantly and it deposits a large amount of stony and large size deposits. With further reduction in the velocity, the coarse sand is deposited, followed by finer sand. The finest particles or deposits are deposited near the mouth of the river or delta. Thus, when the river loses its velocity on gentler slopes, the material carried by it starts settling down. The coarser material gets deposited first and the finer material later. The process of deposition is called as aggradation. River profiles. The development of the river valley may be examined under two heads. 1. Cross profile of the river and 2. Longitudinal profile of the river. The bank-to-bank profile across the width of the river is known as cross profile of the river. It gives an idea about varying width and depth of the valley. The processes involved in the development of the valley, like valley deepening and valley widening, can be explained in the cross profile of the river. The profile of the river from source to mouth is known as longitudinal profile of the river. The longitudinal profile of the river can be divided into 3 sections: the upper course, the middle course and the lower course. Profile of equilibrium or balance attained by the river between erosion and deposition. The river which attains the profile of equilibrium is called as graded stream. If we consider the long profile of the river, in the initial stage, the river mostly undertakes erosion, whereas in the old or the last stage, it undertakes deposition only. In the mature stage, the river undertakes both erosion and deposition simultaneously. The erosion will be mostly in the form of lateral erosion. River is an important agent of landform development in the humid climatic regions where rainfall is relatively high. The geomorphic process operated by the river is called as fluvial process. The work of the river is in the form of erosion, deposition and transportation. The erosion work undertaken by the river can be either mechanical or chemical in nature. The mechanical erosion includes the processes of aberration or corrosion, attrition and hydraulic action. The bank-to-bank profile of the river is called as cross profile of the river, whereas longitudinal profile of the river is the section of the river from source to its mouth.